So let me start the presentation. Like I started to say, my name is Dan Erez. In the past 20 years, I've been a software architect and a software engineer, usually doing cloud architecture, microservices, serverless. I'm from Israel, married to a lovely woman, and have 5 children. Yet I try and find time to innovate on every new technology I encounter. And today I'll tell you my story regarding serverless, obviously. So this is the agenda. We'll discuss the few parts briefly, mainly the future of serverless as I see it. We'll talk a little bit how cloud providers run serverless. We'll mention a few serverless frameworks that you can run in-house. And then we'll get out of the box and I will show you a framework I developed that could potentially replace public cloud providers. A bit of a large statement. I'm obviously exaggerating, but this is the direction. Hopefully we can start a revolution here. Later I'll show you the demo of what I did so you can see it for yourselves. But we'll start a little bit about the future. When someone asks me about serverless and if I think it's here to stay, my answer is a definite yes. And I also advise everyone that asks me to take the serverless first approach, if it's suitable, of course. Not everything is suitable for serverless, but if the application fits, if the use case fits, try to use serverless. The big thing nowadays, at least in enterprises and here at AT&T, is using API management to control all the hundreds and thousands of APIs that an average organization have. And API management and serverless go hand to hand very nicely. Each serverless function is basically one API, and when you manage APIs, you basically manage serverless function. We do it here, and the development is much faster than in scale normal microservices or, of course, monolith applications. Final 2 things I have to say about it is if you look up Joe Amison, you will see that this guy is an amazing guy. He started 3 companies, 3 startups, and sold them using only serverless as the backend. It's amazing. You can hear podcasts or watch him at YouTube. It can be done. Beside that, nowadays there are many startups. I only named a few here. I guess there are many more that create tools for serverless development. So I advise you to search them up or search what interests you in serverless. They do monitoring, logging, debugging, all the aspects of the serverless function lifetime and serverless-based applications lifetime. So check them out. You see that this area is flourishing. There are more companies each month. So I think the future looks promising. And I've started to look at serverless a couple of years back, mainly through AWS Lambda, and played a little bit with it. And later on started to work on that for the applications we develop and put quite a few in production. And the basic idea behind it is, in case you don't know it, that cloud providers try to maximize the utilization of resources, right? They have all this hardware, and if they, for example, utilize 50% of the CPU, they're wasting money, basically. So they have their own sophisticated mechanism and algorithms to do maximum utilization of these resources, and they learn how to do it more efficiently and give themselves more flexibility. And for example, when I started, Lambda had a limit of 5 minutes execution time. And nowadays it's 15 minutes, right? So they allocate more and more resources, more memories is available now. And yet they manage to do smart resource utilization, which is one point that we'll come back to a bit later. And though, as you will see soon, many open source serverless frameworks use Docker or another container to execute serverless functions, Amazon is using a slightly different approach. They use a micro VM called the Firecracker. It is based on the Linux kernel capabilities, mainly one capability called KVM, kernel virtual machine. And it is very similar to a container. They can start very fast. I'm talking about 100, maybe 200 milliseconds for each micro VM to start running. And by the way, this reduces a lot the problem of cold start that you probably heard of, the time that the first call to a serverless function is taking. And it's actually considered more secure than a container. But since nothing is perfect, a micro VM has its drawback as well, besides the fact that it's only for Linux machines. A container is more portable. Containers have been around for a while and have all the knowledge, Docker Hub or other hubs, Kubernetes to manage running containers. So micro VMs are a little bit behind, but I guess they're going to catch up in the near future. In any case, this is the approach that AWS took to run serverless workloads, which is okay. But in this session, I will direct us in-house, right? Because we're talking about a way to drive the public clouds out of business, right? So why would you want to run serverless in-house? First of all, it's easier, it's faster and cheaper to run it in-house because you don't have to upload your code to the cloud. You don't have to pay anybody else. You have more control over the hardware, and yet you retain the option to do a hybrid model, right? If you have a set of servers in which you run your serverless workload on, and suddenly your set of servers is not enough, you need more servers, you can always dispatch them to a public cloud, right? Especially if you run them inside container, you just push the image to some public registry, which is available in the cloud. It can be AWS registry or another registry. And then you can run them on the cloud using your own VM. You can set it up, and there you have a hybrid model. You can even divide it between dev and test environments, and that you will run in-house, and the production environment to be run on the cloud. This is also possible, but during development and testing, you gain a few things if you do it in-house. Sometimes you have to. I did a large modernization project for the Israeli government, and there, due to security reasons, the information is classified. You simply cannot run it in a public cloud, right? It goes to this. It's the same, possibly for banks, for any homeland security companies. they cannot just put everything up on a public cloud. There are regulation, limitations, etc. So sometimes this organization will prefer to run things in-house, and that will be a good solution from them. So to fill these needs, serverless frameworks came in, and there are many serverless frameworks out there. I will shortly review 3 of them, which influenced me the most. Just remember that there's a common behavior or architecture for all of these. They have a gateway, right, to get the requests, validate the request, they apply some security and apply some load balancing. And this gateway decide which server will actually get the request and execute it. And that server, sometimes it's called an invoker, or sometimes it's called something else, maybe just a server. And this server will pull the image from some registry, the image that contain the function, and execute it. And again, there is some load balancing, so you can apply a high load of function calling. This structure will repeat itself. So let's start by briefly looking at the first framework, which is OpenFast. It's very common. You can see that some companies that use it here below. And it follows the same pattern. A call reaches the gateway, it activates function. It can manage the server/containers using Kubernetes or Docker Swarm. It has the flexibility. It has built-in capabilities for monitoring and alerting. We can see the general structure here. It has, like others, again, I'm repeating that because most of the frameworks I encounter has the same capabilities. They usually have some CLI, which you can use to run commands against it. Usually they have some user interface. You can see how many functions are there. You can delete and manipulate the functions, invoke the functions as well. And they have some REST APIs to which the application make a call, the client applications. And the requests are tunneled to their version of Kubernetes that invokes the function on some server. Of course, they use some registry to pull the images, and they have a built-in support for Prometheus or Alert Manager to monitor this whole thing. So you get a full package in this framework to do everything you need. They have support for multiple languages, of course, and it's very convenient to work with them. Another similar framework is OpenWhisk, also available as open source. Now it's Apache. It's developed by IBM, and it is used by IBM as part of their own private cloud solution. They put an emphasis on loosely coupled elements, which means they give you the ability to invoke functions in an asynchronous way, right? Not just through a REST API, not just through a synchronous way, also asynchronous. This goes well with event-driven architectures or some other architecture in which you don't need to get the result immediately. So you can use Kafka or a different event broker. And it looks a bit like that. They have an Nginx web server that routes the request to a controller. This controller registers the request on a CouchDB database. And if the call is asynchronous, it dispatches them to Kafka. And there are one or more invokers, one or more servers that gets a request. The first one that pulls the request start the image locally and execute the function and returns the results, of course. So this is OpenWhisk's model. Very similar. The last one is Oracle's FN project. Also very similar, has a gateway, which they call the load balancer, have the FN servers to actually execute the functions inside. They do have support for async. Actually, I like this framework the most. It was the easiest one to start and integrate, although I guess it's a matter of personal taste, but I found it to be the easiest one. And this is their architecture from their own website. You have requests coming in, a load balancer, similar to other frameworks, dispatches it to a server, and results can be stored in a database. Activation logs can be stored in database, and some registry is used to fetch the image and start a container instance with the function code inside it. So I was looking at this project and the fact that you can run it in-house, and I liked it a lot. And then I started thinking, well, in these scenarios, you still need servers to run the Kubernetes cluster or the Docker swarm, etc. But I realized that in-house, we actually got many servers sitting around. I can give you a concrete example. In AT&T, there are over 250,000 employees and machines. And the average use of a machine is very low. And even that for a third of the day, right? Let's say if an average employee works for 8, I don't know, maybe 9 hours per day, most of the day, his machine is idle, basically, right? For most employees, I know that some can run some workloads and go home, but for most employees, they have an idle machine for most of the day, right? And even if they use their machine, if they write, for example, Word documents or even writing code, most of the time, they don't utilize their machine and leave tons of CPU and memory and hard disks idle. This is a big waste, right? If we look at, for example, those 250K machines and assume that only 20% of them is available at any given time, and ATD is a global company. They have offices and workers all over the world. So if we be modest, 20% are available at any given time. This is 50,000 machines, and these are strong machines. For example, the laptop that I'm using right now is a modern i7 with 6 cores, which is with hyper-threading, actually means 12 cores, and it has 32 gigabytes of memory. And currently I don't know if I even use 30% of its power. So we have 50,000 servers just sitting there all over the world doing nothing, right? So when I realized that, I thought that this machine can be used to run some workloads, right? And maybe they're not suitable to be like a long-running server. So monoliths or microservices are less suitable because they always have to be up and running. But only if I had some short-lived code that runs for a short time and doesn't use a lot of resources, then I realized I have one. serverless functions. It's a great match, right? Because it has a memory limitation everywhere, right? We just saw that Amazon limits us to 10 gigabyte of memory. And the default, by the way, is 128 megabytes. So we can run a lot of function on my machine that has 32 gigabytes available most of the time. And they run for a short period of time, right? So if I could only sync and manage all of these servers to know which one is available, I could have run millions of function calls easily without paying a cent to any other cloud provider, right? And at this point, I also remember that someone did it before, a long time before. So those of you who are old enough to remember SETI, the Search for Extraterrestrial Intelligence, those guys, it was a project to search for life in outer space. And those guys asked you to download some application that reside on your desktop. And when your machine was idle, which is most of the day, apparently, they used it to do some calculation for the space center. I think that at the prime, they had a few, maybe over 10 million machines at their disposal, which is a huge computation power. Well, they didn't find life in outer space yet, but they showed that this idea is possible. So I went ahead and did it, right? And I did it, for example, in my own organization. But if we can imagine looking forward, we can do this kind of resource sharing the same way SETI did between organizations, between people, even outside organization. And maybe they can even get paid because they save money for the organization, so they can get paid a fraction of the cloud cost. I don't know. I didn't get that far. And I wanted to tell you the stuff that I did do. The architecture was heavily inspired from the frameworks we just saw. So I do have a gateway. And the life cycle is like that. A developer writes the code of function the same way he would do in every serverless framework, right? And the language is irrelevant. And when he's done, he can deploy his function to some internal Docker registry. And in parallel, you will update this gateway that acts as some central information about the function. And on each machine, each worker desktop, for example, it can also be mobile phone if you'd like, as long as it's on the same network and reachable from the gateway. There's this agent that runs in the background. Currently, I've implemented it as a Docker container as well, but it doesn't have to be. And this agent constantly reporting the gateway, their status, the status of the host machine, right? The CPU, the memory, other factors are available as well. So in every minute, the gateway has a total view of its server. It has a map of the available server and their average workloads, so it knows which ones are available. You can also know their location if that's important. We can take it further. And if we want to keep planning ahead, we can also use some machine learning to predict which server is going to be available on which times. For example, in Israel, we don't work on Fridays, but we do work on Sundays. So the gateway can be smart enough to know ahead of time which ones are available. And you can, like I said, add the location of the servers and the caller into account and match the two of them together to get the best response time. And when some user is doing the API call, the gateway, which already knows which server is going to address, pass it the call along with the parameters, and the agent here downloads the image from the registry if it doesn't have it already. Run the container, pass the parameters via the standard input, gets the response via the standard output of the container, and return it to this gateway. Currently, I didn't support any asynchronous model, but it can be done in the same way with some message or event broker. And this framework was built and tested here, and it works perfectly. So let's see it in action. Okay. Currently, I have only I hope you can see the writing. I hope that it's big enough. I have only the registry that started, and I have my gateway running here as a Java application. Now I can start the agent. Since I have only one machine, I'm going to start 2 instances of it on the same machine. This is the first runner, and on a different port, I'm going to start the second runner. So if we take a look here, we're going to see the two of them are running at different ports. And I also added a little GUI to the equation, as most of the frameworks do. And here we can see the two agents that are available, hostname and port, and the fact that I didn't call them at all because I just started it. So it makes sense. I added the last code to see which runner, which agent gets called by the gateway to apply some different dispatching algorithms to see how the calls are being distributed. So now I have 2 agents running. I can deploy my first function. Let's take a look at the code. This is like the simplest function possible. It runs through the main. It can address many requests while it's up. And basically what it does, it just read from the standard input. This is the way I communicated with the running containers. You can have other options as well, but this is the simplest one. I get the payload, pass it to the actual function code, and write the result to the standard output. And I'm doing just the addition of the input number to itself and return it. To make the deployment easier, I've written a small plugin to Eclipse to do the actual deployment. When I do that, it may take a few seconds because it build the function, run the Maven install, build a container, and push it to my local registry. It deployed successfully. You can see that as well here in the gateway with this log. So now I'm supposed to have a function ready. By the way, I didn't show you, but those agent reports their statistics and free memory every few seconds. Let's just check that we have the function here. Here it is. So let's invoke it. The first time, it's going to take a few seconds. Remember what's happening in the background, right? If we'll go to the slide here and return to the high level look, I hope it's more clear when you see it in action. I was here, right? I show you the code of the function, doing when I use the deployment plugin. Behind the scene, I've built the code, wrapped it in a jar, wrapped it again inside an image. I've built an image and pushed it to the local registry. In parallel, I updated the gateway that it has a new function and the image name, so it can invoke it later when it passes it to the agents. And now we are here. We try to do a call. So this is the first invocation. And there we have it. It didn't take too much time. And we got the addition fine. So that was this part. We call the API. The gateway looked for a suitable agent. It has two, so we picked one and passed it the parameter and the image name. The agent, which is again on my machine, pulled the image and started it. So that was it. And if we take a look again at the servers, we see that there was a call that was made right now. Now, if we do another function call, I expect the second server to come into action. So let's try that. Again, we get an answer. And now we see that the two servers were active. Now, if I call that again, I hope the call will be faster, but that depends on the amount of time since the last function call. We can see that here we have only one function alive because I configured the agents to kill a running function after 30 seconds, right? If I will talk long enough, I will see that these functions are dead. So in a second, I will reinvoke them. I just want to say that this is also a matter of configuration, right? I can keep it this way, hard-coded 30-second time to live for a function. I can be smarter, right? I can measure the rate of calling for a function and don't kill it so fast, right? I can keep it running and I can be even smarter and track the workload and the number of times each function is called and even start a function ahead of time, right? If I know that, for example, in the morning, everybody logs into their systems and start doing some business procedures that they do each morning, and on the back end that translate to certain functions that are being invoked each morning in a certain amount. I can do the pre-start of this function in a suitable number to accommodate these requests, right? And no one will feel, and the cold start effect, although it's like a second or two, won't be noticeable at all, right? So this is one option. And again, this framework can also be used to run batch processes, right? It doesn't have to be synchronous, although this is the simplest use case. That's why I started with it. But when you think of it, you can submit a batch job, which maybe involves a flow of function, like Amazon step functions, for example. Function A called function B and C, and the result is passed to functions C and D. And the gateway can be smart enough to execute this flow of functions when resources are available, right? So even heavy organizational work that usually happens during nighttime to save resources, etc., especially if there's a mainframe involved. They can be done throughout the day in a smart way. When you go, for example, when you go to lunch and you leave your machine running, the gateway, boom, we recognize it and start exploiting your computer to run its workload in a smart way. So finally, let's execute the function a few times to let the server start the function, and we'll do it before we'll rerun them, re-execute them before the 30 seconds are over. So this is probably the first server. And let's do the second one. And now if I do it, let's take a look, and we see that both functions are alive, I expect a faster answer, and I get it almost immediately, right? So when servers are up, the response is almost immediate, which is a good thing, right? So for this simple UI, we can control everything. If I've, excuse me, if I deployed more functions that see them here, I can control them, invoke them from here, delete them, edit them, upload the code from here. This is really easy. Sorry for the ugly UI, right? But I can do everything from here as well. But like you saw, it's fairly easy to do it from an Eclipse plugin. So it's easy for a developer just write a simple function, and function should be simple and short and do one thing only, and they can deploy it from here. Okay, so now we can summarize. Right, so I think that all of you, since you are here in this conference, believe that serverless is the future, maybe even the present, and are avid advocates for using serverless. If you still pay cloud provider for serverless, reconsider, right? There are many in-house serverless frameworks that you can use on dedicated servers, as is, like we've seen OpenWhisk and FN and OpenFaaS. And you can easily modify them like I did, so you can run your functions on anything, right? Any available resource can be used to run your function, and you can do the management as smart as you want. You can do a simple round robin between the servers based on utilization, based on whenever you want. Check with your organization and see how many resources are not being fully utilized, and utilize them, save a lot of money, and have a lot of fun in the process. Thanks, everyone. And left a few minutes for questions if there are any.
So, thanks, Dan, for your awesome talk. Usually the audience would now be giving applause, but maybe you guys at home can use the Swapcard chat for that. Unfortunately,